Hi boys and girls, welcome back. This is Miss Elliott and we are going to be talking about our iReady lessons for the week of April 13th through the 17th, 2020. I hope you guys all had a lovely Easter holiday and that you guys got plenty of rest. This week in iReady, we are going to be doing 2 math lessons. One of the math lessons is taking everything we've talked about, maybe over the past 3 weeks, and we're going to put it together and we're going to use them on choosing the best center of variability. And that's what the first lesson is. The first lesson is the choice of measures of the center of variability. And then the second lesson is histograms. So the first one, the choice of measures of the center of variability, that's reviewing the mean, the median, and the IQR. Now the mean, that's something you guys know very well. That's where you find the average of all the values in your data set. And then we have the median. That's the halfway point or the middle of your data set. And then we have the IQR. IQR is the interquartile range, and you're going to hear it referenced as IQR on your iReady. That is the measure of spread. It is the range of values of a frequency distribution between the first and the third quartiles. And you're going to see it used with the box plot. Remember how we did box plot 2 weeks ago and they were talking about IQR? That's the interquartile range. And then we have the outlier. That outlier is the data point that is the farthest away from the expected mean and median of your values in a data set. And the outlier could look like that. And the outlier, when you have an outlier, the mean and the median are going to be far apart. Do you remember in class when we took the data set of everybody's age in the class? And the values of the data set of the students, the value of the students was clustered pretty close together. It made a very symmetrical, very nice little dot plot right over here. And then we included my age way over there. We had one dot way, way far away. So the mean, the median, the middle, that was not affected. That still stayed the same. But the mean, because we had to include that data point, it moved the mean farther away from the median. Now, we had questions about why we included that outlier, because it kind of skewed the data. But we have to include it because every data point in a value set is important. So that's why we included everybody's age when we were trying to figure out the ages of the students and the teachers in the classroom. That was a fun lesson. So that brings me to this. Here are some more vocabulary words. We have symmetrical. Symmetrical means that the left half and the right half match perfectly. They are exactly equal. Now the mean and the median are going to be the same when you have symmetrical data. Now, if you have an outlier, like we did with my age in that little value set, then that data is going to be skewed. That means the data on the left may be very different from the data on the right, or the data on the right might be very different from the data on the left. But even if the data is skewed, we have to use every point of data because it's important. So for this one, when we have really large outliers, the mean is the most fair center of measure. So these are just some vocabulary words and some points I wanted to review with you before you started doing your iReady lesson. As I said earlier, when you're doing your iReady lesson, if you are doing the lesson, you did the practice, you get to the quiz, and you get a score that is maybe not something that you're very happy with, something that's below a 70, call me, email me, text me. we can go through that, and we can go through the quiz, and we can make sure that you are understanding each one of these terms when you're applying them to math. So it's going to be a lot of fun, but don't forget to reach out to me. I can help you with this. The second lesson we're going to talk about is histograms. And histograms are pretty cool. They look a lot like a bar graph, and we're going to talk about the differences here in a second. But a histogram, this is a continuous range of values in intervals. So if you look at my histogram example over here, we're talking about, we're talking about the height of trees. And we're measuring the height of trees in centimeters. Over here, this tells you the number of trees that were measured. And then I have these bars to represent the height. Each bar is called a class. So right here, between 100 and 150, I have 5 trees that were that tall. Over here from, 200 to 250, I have about 25 trees. If I wanted to see how many trees were shorter than 200 centimeters, I would count this group of trees, which is 30, and this group of trees, which is 5. And I would add that together. 30 and 5 is equal to 35. So I would know that 35 trees are shorter than 200 centimeters. I don't know how many trees are 100 centimeters, how many are 104, how many are 140. I don't know because this is grouped together. But I do know that 5 trees fall between 100, 150 centimeters tall. This also lets me see which one has the most, which one has the least. All right. So you're like, that looks an awful lot like a bar graph, right? Well, it's a little bit different. This histogram represents the frequency distribution of continuous variables. Like I said, I don't know. This is not exactly one for the other. In a line graph, I would have one line that would represent, or a bar graph, I would have one bar that would represent the trees. This presents in a histogram its numerical data, where a bar graph shows categorical data. And in a histogram, there's no gaps between the bars. But in a bar graph, there is a gap. So here's a little bit of the differences between the two. So that is going over our lesson for this week on iReady. And I'm really excited to see how you guys do. You guys did great last week. Oh my gosh, that was so much fun. So give me a call and I can help you. You have a lot of teachers here that are here to help you be successful in your math and in your reading and in your world history and in your science. If you get stuck in any of those lessons while you're at home, please call me, text me, email me. If I don't get back with you right away, that just means I'm working with another student. And as soon as I'm finished, I'll call you. Okay? As always, I'm here for you, so stay safe. Stay safe. Wow, I still can't say that, even after all this time. Okay, stay safe, stay strong, and stay healthy. All right, I'll talk to you soon. Bye.